Hello everyone, this is Dr. Petrola again coming with the math functions for your SEM 1 portion. So let us begin with our math functions. Let me start with the maximization of screen. Alright, there we are, these functions. So we are going to understand first the meaning of function and then we will see what are these math functions that are all about. So we talk about the function, the meaning of the function. So in general we have learnt in our function chapter as well, function is nothing but a method or a module which is nothing but performing one task. So larger program is divided into small processes, one task. We do them, we perform them, we write them separately, and then as and when we require we run each and every function into the hierarchical order. So when a large program is broken into a piece of small and easily executable tasks, we call that as functions. Now, as far as Java is concerned, Java has a rich library of lot of functions which are called library functions. They are already defined by Java for general needs, the common needs of the programmer and the user. However, there are certain functions that needs to be created by the programmer for the specific needs of the user. They are called user defined function. This is going to be discussed separately in a chapter. We are going to focus here on library functions. Library functions. So here, what do we call them? The library functions are ready-made functions. Of course, they are supplied by Java. So Java has recognized the need of a programmer that certain things needs to be commonly needed by every other programmer. So for that, there are certain ready functions available. You don't need to waste your time in thinking logic for them. Your focus should be on the needs of your client. What is a program requirement? If there is anything specific requirement which is already defined by Java, then you should use them so that your time is saved. At the same time, you will be able to focus on your logic of your current program or the program of your client. Now, these are called general purpose function. It means these functions are required by many of the programs and they are available in all parts of program. Let me also add something over here. All the functions which are derived by Java, they are public in access. It means every class, subclass, packages can easily define them. Alright, they are public in nature and all of them are return type. So they will return some type of a value. When you apply a function, function will process and will return us a value as a final answer. So there are examples of a lot of math functions. So you're going to have various names of various functions over here. Even string has got a lot of functions. Alright, and they perform only one task, one specific task. So as and when we go ahead, we'll try and understand what each task means. So let us begin with our first function. Our first function is Math.sqrt. Now what is this? So in this case, your math is a ready-made class provided by Java. This is a class and this is a function name. So all the function name will be different. So logically a dot operator will help us to go to the math class math and run the function by supplying some set of value. Now there are few things that you need to learn in this particular chapter which can be very useful in MCQ as well. First thing, you need to know the meaning of the function. Okay. Second thing, you need to know what the function will return, that is the output. Third thing you need to know is what is the type of data that will return, data type of data. What type of data it is going to return, that is very important. Fourth, if at all a particular function is used in an expression. So Java, when you are writing mathematical formula in Java, if there is any function, you can make use of that. And of course, fifth one, you need to know examples. And of course, syntax as well. So these are the 5 things that you're going to focus on. So we're going to begin with first understanding the syntax over here. Alright, and the meaning. So first start with the meaning. Functions return, this particular function returns a square root of a given positive number. So any number which is positive, square root of the number if you really want to find, here is a function called Math.sqrt which is returned. Because it's returning, you need to have a data type to store. Some variable is equal to the function, any expression or a value, either of them, whichever is applicable, you apply and you will get the return value Math.sqrt of that, and it returns a double type, decimal type value. Very important. This can come in your even in your MCQ type. So if I say Math.sqrt of 25, it means computer will find square root of 25 and will return. Because it's returning a decimal type, the answer is not going to be 5, but it's going to be 5.0. Okay, so because it's returning, I can print it directly, or I can store the value. So when Math.sqrt is going to return a value, say 49, square root of 49 is 7.0. So when 7.0 comes, if there is a variable, then I must have a data type as double. No other data type will work here. So the value will get stored as 7.0 and print will print. However, if you try to apply a negative number here, then you will get a message on the screen, on the terminal window. You will get NaN, which means not a number. Negative number, it doesn't apply. So here is the example that you have. Okay, we will first do the CBRT also, and then we'll take the example. Two functions at a time. You have the next function that we have is Math.cbrt. CBRT is going to return the cube root of a given number. So whatever number is defined here, given here, it will give you a cube root. So what is your syntax? Again, it will have a data type, variable, Math.cbrt. You can have an expression or a value directly. So if I have Math.cbrt of 125, then cube root of 125, which is supposed to be 5. So 5 cube, you say. Cube root of you can say 125 is 5.0, because the function returns always a decimal type. You will not get 5, but you will get 5.0. Again, this being a return type function, either you're going to print or you're going to store the value. So this is 343 is 7 cube. The answer will go into x, then x must be of a decimal type. So x is storing 7.0 and we can print it. So if I have to see this in your program, then let's see here. So here is a set of function values or statements that we have. I'm sure you are able to see this. I'm trying to increase the font size. Yeah. So here is very simple Math.sqrt of 9. So this answer is technically 3.0. This is going to cube root, 2 cube, 2 raised to 3. Alright, so answer is 2.0. So this 2 will give you 3.0 and 2.0. Now if the answer comes in decimal, I must have a decimal type data. A has to be decimal type, anything else will not work. Even if I apply float, the moment I click here, I will get an error message, incompatible data type. So I must have a decimal data to store. So sqrt will store a square root of 25, cbrt will store a cube root of 125, which in both cases will be 5.0. So this will give me 5.0, so as this will also give me 5.0. So you'll get 3.0, 2.0, 5.0 and 5.0. Let us see this answer. 3.0, which is a square root of 9, 2.0 is a cube root of 8, 5 is a square root of 25 and 5 is also cube root of 125. So this is how the values have come. Then we have the next set of functions that you're going to learn, two of them together. One is on Math.max and another is a Math.mean. So since mean is come first, we will try and work out on mean. So what does the meaning over here? The function will return minimum value, that is a lower value between the two arguments. So there are two values given, between them whichever is lower, Math.min, min is minimum, short form of minimum, will be returned to us. So now I am going to give one number here, comma, there will be another number. Whatever is a lower number will be returned, alright, and the variable is there. But here the return type is a little dicey, so you need to understand, if your input values, your values inside a min is of integer in type, then your return is going to be integer. Okay, so if I say Math.min of 5, 2, then 2 is the minimum out of the 2, so that's my answer. If it is 7, 4, obviously 4 is a smaller value than this, so x is going to store that value. Since the value returned is an integer type, the data type is an integer type, so my answer printing will be 4. However, there is one very important thing that we need to know. When the data type is going to be decimal, then my storing type has to be decimal. It cannot be integer then. So based on the input value into a bracket, your data type will be determined. So here obviously 4.6 is a lower value, but when you have one integer and another decimal, then I hope you all remember the implicit cast concept. Implicit cast concept says when two data items are given to you of two different types, whichever is the greater, the other data type gets converted into that type. So between them double is greater, so computer will convert 3 into 3.0 before the answer is derived. Therefore the return data type has to be double. So between 3.0 and 4.6, 3.0 is a lower value. Alright, it follows your implicit cast. And if the values are same, then your answer will also remain same. So your data type is going to be depending upon what the values are there in the bracket. Same concept will go with max, except the max is going to give you the greater value between the two arguments. All other rules will remain same. So math.max of argument 1, comma argument 2. Again here between them 5 is a greater number. Since both of them are integer, my return value is 5. In this case 7 and 4, maximum value is 7. Since both of them are integer, my storing data type is going to be integer for my variable, and they will print 7. Okay. However, if you really want, you can make it double over here, because anyway double is a greater data type than integer, so it can take, then your answer will be 7.0. But ideally when there are two integers, your best data type should be the same. However, if both of them are decimal, your storing data type has to be a decimal value, and your answer will also be decimal. But when it is one of them integer, another decimal, same way implicit cast what we applied in min will apply over here also. So 3.0 is a decimal, 4 is an integer. So first computer will convert this into 4.0 as a decimal, and then between them the checking will be done by the function. So return value will be 4.0. And of course, when both the values are same, your answer will remain same. So in this case, suppose if I am going to take you to the programming side. Okay, then you have math.max and mean. So here is some set of functions that I have taken randomly. Okay, the first one here is says 5 and 7. Okay, so obviously we know 5 and 7 will return me, in case of mean, is going to be returning me 5. Now here the decimal value will also be applicable. So let me just disable few lines over here, so we will be able to immediately catch hold of those values which are available for us for run. So 3 values will take, 3 lines. 5 and 7, of course minimum value is 5, so we'll get 5. Between 2 decimals, so obviously between them negative value will be minimum, that will be your answer. Between these two also minimum value. So if I say minus 8.9 and minus 8, my answer is minus 8.9. Okay, so this answer should come minus 8.9. So if I compile, run. Okay, now suppose if I am going to add few more lines which are here, so we add 2 more lines which are my min function. Then between minus 3 and 2.6, now we know minus 3 is smaller, so it will give me as minus 3.0. Whereas when the numbers are integer, my output will be integer, irrespective of whether they are what you call the positive or the negative numbers. So the last two answers that we need to focus on, minus 3.0 and 5.0. So this works with the min. Same logic we are going to apply with max. So all the output now after max function are going to be tested. So let's take first 3. Between 5 and 7, of course being integer, your answer is integer. Between 12.6 and 13.8, your answer is 13.8. And between these two, minus 8 and 8.9, your answer is 8.9. So 7, 13 and 8.9, these are your last answer. These are the maximum value between the two into a max function. So you can see these 3 answers have come. So your output is derived by the values that are there inside, whichever is a greater in their data type. So if I add, okay, this will be the last one. So if I add here minus 3 and 2.6, so 2.6 being decimal is a greater data type, so computer will convert minus 3 into 3.0, though the number is greater. So if I put minus over here, then minus 3 is smaller than minus 2.6, so your answer is going to be minus 3.0. And of course, if the numbers are same, your answer will remain same. So we'll focus on the last two answers. You can see here minus 2.6 and 5.0. So I hope you guys have understood. In ICSE, you can be asked a question with the multiple values. So when you have multiple functions, not multiple values, multiple functions. So if I have a function inside a bracket, then the inside part will work first. So between these two, minimum is 12.9. Between these two, max is 13.9. So 13.9 and 12.9 is your return value of these two functions. Between them, the minimum is 12.9. So your answer will be 12.9. So you can have a function, a particular line which has a multi-functions being applied to get you the answer. So I hope you guys have understood the mean and max. Now, let us move to the next set of functions. So the next set of functions that we have is Math.pow, highly used function in programs. So here your function returns, POW is a short form of power. So when we say power, 2 to the power 3, 4 to the power 2, like this. So this function returns and calculates and returns the base value to the power value. So when I say 5 raised to 2, 5 is my base value and 2 is going to be my power value. So whatever is my base, I will provide to the power value which I am going to give in my syntax. So what is the syntax is? It says math.pow of base value comma power value. So your base value needs to be applied here. To the power you will apply here. Computer will calculate and return. When it returns, we will be able to store that value in a variable. You need to define a data type which is fixed as double. So you can't write anything other than that. So if I say math.pow of 5 comma 2 is as good as 5 raised to 2. 5 to the power 2 is 25, but because the function returns a decimal type, the answer is 25.0. Similar to this, suppose if I am storing a value, 3 comma 2 is 3 raised to 2, then the value that is going to store in x is going to be 9.0. So since it's a double type return, my data type should be double. So when I print, my answer will come this. So as I can also define a set of variables, so this could be an expression. Okay, so if I say a plus b, so computer will apply 3 and 2 over here. 3 and 2, 5 comma 2 is 5 raised to 2. My answer will be 25.0. Even if my inside values are integer, my output will always be decimal type. Okay, so here is what your function is, power. So this is going to return 7 to the power 3, which is supposed to be 343.0. 5 raised to 2 is 25.0. Since the return value is of a decimal type, we have written here double. Print will print 25.0. And of course, the same function which I have shown you just now, a plus b to the power 2. This is also going to be, let's make this to let's say 4. So 3 and 4, 7 to the power 2 is going to give me 49.0. So if I run this program, you can see all answers are in decimal. Now, again, like I told you, this I cannot change. Even if you say float, the moment I click elsewhere, the error will start appearing. So you need to understand that you cannot have any other data type except double. Then the next function that we have in the hierarchy over here, so let me just, the next function that we have in this hierarchy is math.abs. Math.abs is an absolute value. So absolute value is again a very important function. It basically returns you a number, alright, a positive number of whatever absolute value, that's a positive number, converts a negative number into positive without losing any decimal places. So it returns you a negative number into positive form without losing any number, but the positive will remain positive. Okay, so suppose if I say minus 4.5, it will return me 4.5. If I say minus 3, it will return me 3. Now if you try and understand this way, if my values inside the bracket is decimal, my output is decimal. If my value is integer, my output is integer, like max and mean. Here the output of the function will be depending upon what's the value is inside. So because this is integer, I can safely write integer, but if this would have been a double value, then I have no choice but to write double. So this one will return you the decimal value. Let us see your program over here. Looks like system is giving trouble, so we'll stop here. So let us check our program as how absolute will work, math.abs will work. So here is a program, here is a small explanation how the function will work. So we've got a function here, math.abs of minus 5 will definitely return us 5 because it's an integer. But when it comes to here minus 5.4567, then the answer is going to be 5.4567. This entire value will come without losing any decimal point. Here, since the value is integer, so the data type storing should be integer. Ideally, you can use safely, though you want, you can use the higher data type also, but it can work with integer and we print it. At the same time, because this value is decimal, my data type must be a decimal, so it will print that out. So if I'm going to run this program, here is the, alright, so it's a print statement. That's how the answer is coming all haywire. So let's make this println over here, so we'll get answer all in different lines. So now if I run this program, you'll be able to see this program output integer as returned an integer value, decimal as returned a decimal value. So there is no fixed data type as this, it will be depending upon what the data type is inside. Then the second set of the next set of function rather that we are going to learn is going to be the ceil and floor. I don't know how many of you have done this ceil and floor. Ceiling of a number. So ceil is rounding of a number. So there are three functions that we are going to do about rounding a value, rounding of a value. So I'm sure we all have done in mathematics rounding of values. Now in mathematics, when we do rounding off, alright, after the decimal point, if the value is 5, the first digit is 5 or more, alright, or more, then the round off goes to the greater side. And if it is lesser than 5 anything, then it is to the lower side. That's your mathematics. But in computer there are three functions. One will compulsorily take you to the higher side, another function will compulsorily take you to the lower side, alright, and the third function that you're going to learn is going to follow your mathematical function rules. So all functions are available to us, we need to learn each one of them. So let us see first one. We have math.ceil. Now always remember, if you really want to understand the concept, you can also draw a number line. On a number line, of course, there will be 0, 1, 2, 3, 4, 5 and so on. So as minus 1, minus 2, minus 3, minus 4, minus 5 and so on. So assuming that you have a number whose ceil value, the greater value. So what is this ceil value now? So ceil value is going to round off your number, is going to be rounding off your number, alright, and return the nearest higher whole number, a nearest higher, whichever is the number to the point from where I am going to write. So nearest higher. So assuming here is a point, my pointer is here, let's say this is 2.3. Then the nearest higher number will always be on the right hand side, the number which is greater than this number and a whole number, which is 3. 2 is a smaller number. Okay, so ceil will always give you the higher value from the point, even if your number is, let's say, 4.1, which is supposed to be somewhere here, but still the nearest higher number is here. So ceil is compulsorily going to give you the higher side. Now again ceil floor, or rather say ceil, is going to return you the data of double type only. So even if the number is going to be a kind of an integer, nearest whole number, but the value will be always in decimal. So I can either print it like this, or if I'm storing a value, then the variable of the storing variable should be of a data type double. So 3.9, again if my pointer is somewhere here, 3.9 will be somewhere here, still my nearest higher value is 4.0. But when it comes to negative, so it says minus 4.6. So let's say somewhere here minus 4.6 is here, then your greater number is still on the right hand side to give you minus 4. So you need to be more careful with the negative number than the positive numbers. Positive numbers very easy to find, greater, smaller, but in a negative number you will have to be very careful. Minus 5 is a smaller value, not the greater. Minus 4 is greater, so your value going to return is minus 4. Very close to this, but exactly opposite is your floor. Floor is going to be the lower side. It's a very simple concept. So if I am going to make some guy standing over here, alright, you will find the ceil is always the higher side, that's a ceiling, and floor is always the lower side. So if you are standing, floor is always lower, so floor is always going to round off the value to the nearest lower whole number, okay, and it also returns you decimal type. So your function syntax is going to be math.floor, any expression or a value which is going to be rounded off to the nearest lower side. So if my number is number is going to be 4.1, so again on a number line 4.1, the number smaller than 4.1 is 4, so it's being rounded off. So as number 3.9, the smaller than 3.9 is 3.0, not 4. Since the data type return is double, my storing variable must be of the double type. So as what if the number is minus 4.6? So I'm going to take you here back. If the number was minus 4.6, this is ceil part, this is floor part. So floor is going to give you minus 5. So that's how your number is going to be, minus 5.0. So I hope you guys have understood this. Let us take a practical from this, that if my numbers are here, so I'm going to take a ceil first. So I've got a range of values, okay. I've kept a demarcation line here, which is supposed to be, of course not this, which is going to give you the numbers. So as I told you that the number after digit after decimal is going to be crucial. So if it is 5 or more, ceil will always go, or no, sorry, not 5 or more, anything above 0 is going to convert everything into higher side. So this all will give me 4, or 4.0 rather. Only 3.0 will remain 3.0 and 4.0 obviously will remain 4.0, but all of them will go ceil, which is going to be higher side 4.0. So if I'm going to run this program and run, I'll get, except the first one, everything else is converted into 4.0. Then same thing we are going to also do with floor. So if it is going to be floor, obviously 3.0 will remain 3.0, but they all will be rounded off to the lower side. Now lower side of 3.1 or 3.9, everything is 3.0. So only 4.0 will remain 4.0. Everything else is going to give you 3.0 is the answer, because the lower value, then my 3.1 or 3.2, 3, 4, 5 up to 9 is all 3.0. Now let us go back to ceil and say, what if the numbers are negative? So let us put a negative sign in front of everyone to make us understand how it is going to convert it into a negative value. So I'm going to keep minus 4 as well. Now you can take a pause, imagine a set of value and see whether your answer is going to be same or not. So your pause now. So I hope you must have paused and checked your answer. Now if I'm going to run this program, so remember this ceil is going to be higher value. So minus 3.1, the higher value than my minus 3.1 is supposed to be minus 3, not minus 4, okay. So this is supposed to be minus 3 in all cases, okay, but only minus 4 will remain minus 4. So here is my answer. You can see all of them are minus 3 except the last, which is anyway minus 4.0. Same thing if I'm going to apply here the negative values, okay, with the floors. So now we know a value which is lower than this number. So a number which is lower than minus 3 will remain, of course, minus 3 because it's point, there is no other value here. But lower value than minus 3.1 is minus 4 and not minus 3. Minus 3 is higher, minus 4. So this is all going to give you minus 4.0. So there, I hope you all have a proper learning time. Then the next function, it's not a set of functions, next function that you're going to learn is going to be Math.round. Round is following the exact mathematical principle. What is a mathematical principle? Says if the value digit after 5 decimal is 5 or more, then the conversion is going to be higher side. That is higher, round off to the nearest higher whole number. And if the number is 4, 3, 2, 1 or 0, then all this is going to give you lower. This is all higher. Okay, for the positive number. For a positive number. So let us see if I have a set of positive numbers. So that is all depending upon what the value is. So here, so let's say I have all the numbers which are positive. So I've got 3.0, obviously there is nothing changing 3.0 and 4.0. But 3.1, since 1, 2, 3, 4, these are all lower than 5. So their conversion will be lower side. 5, 6, 7, 8, 9, since they are 5 or more, their round off is going to be higher side. But one thing very important, this has a very good chance of coming in the ICSE, is what type of data it returns. Alright, it returns an integer, that too of a long type, not an int type. So very important. Alright, it is going to return an integer value but of a long data type. So let us first see the value. So all this thing is expected to be 3.0. From here everything is expected to be 4.0. This will not give you output because there is no print statement. So we will see first. You can see all of 3.0, 3.1, 2, 3 and 4. These are all 3 and 3.5, 6, 7, 8, 9 and 4.0 remains 4. So your answer is in integer, not in decimal. Very important. Round is a peculiar, a very specific function with a integer type. But it has to be long type and not int type. If I type int, the moment I print my program, print my data, if I try to say copy and paste, I want to print X value. Okay. Then if you see here that the moment I click, it is giving me an error message. Alright, it says incompatible data type, possible lossy conversion from long to int. So the data is supposed to be long, but you try to convert into int. So except long, of course you can write double or a float because they are greater than long, but logical returning will always be an integer type. So this answer will also be 5.0, or sorry, not 5.0, only 5. So this is how you got it. Then most important part where lots of children are confused is a negative number. So if I'm going to apply minus, so there I'm applying minus. Now remember, again this follows the same rule. In negative, this is going to be converted into higher side because these are 5. It goes exactly opposite. So now minus 3.5 will not become minus 4, it will become minus 3.0. Minus 3.0 because that number is a higher value than minus, whereas this will go to the lower side, exactly opposite. Okay, to make it minus 4.0 till here. So here the 0.5 is going to be not counted with this, but because it's going higher side there, so it will be counted over here. So remember this, minus 3.0, minus 3.0, minus 3.0 till here. This is going to be minus 4.0. Okay, so you need to be very careful with this, is highly logical. There, minus 3.0 and everything, and minus 4.0 and everything. Of course, the last value we did not do anything, so it remains 5. So I hope you guys have understood this. to understand what is a Math.round is going to return. You should practice these programs, or rather say the lines. It will help you understanding the concept really well. So round is very important. Only function that returns compulsorily integer type, but of integer value, but of a long data type. Okay. Then the next and the last function that you have here, the next and the last function, for which I don't need any PowerPoint now, is your random function. Very tricky, very good, and very important function. Use in many programs which has a gaming concept. Alright, randomly something should take place for that. Math.random. A random function will return you always a decimal value between 0 and 1. One random value between 0 and 1. It is neither going to be 0 nor going to be 1. So in this case, if I run this program, you will find one random value has come. Okay, that's the first meaning of this function. So since I don't want once the value again and again run, I'm just applying a for loop. Okay, for int I is equal to 1, I less than equal to, let's say, 10, I plus plus. Now this is not going to give me a random number up to 10. This is just a random number, 10 random numbers. So I don't have to run the program 10 different times. I'm going to run only once and I'll get 10 different random numbers immediately. If I run this program, there we are. You can see this function. Now what is the important thing that we need to learn? Alright, from here, what if I multiply each number by 10? Then you will find that one digit will move to the left hand side. So I'm going to run this program, okay, by writing like this. So I'm going to do one thing. I'm going to say here, say double, because it's a big decimal value. Say double x is equal to, I say math.random. So obviously we are going to get a number which is going to be a random. Now I'm going to print that number x over here. Okay. Now I'm going to say copy this from here and paste it over here. And I'm going to multiply the same number into 10. So you will now know, if I multiply it by 10, my one number digit will go onto the left hand side. So 10 random numbers are generated. First number is this. When you multiply that number, one digit has gone onto the left hand side. So make it 9. Everything else is here. 0.62 blah 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 is multiplied. 6 has gone onto the left hand side. Every other value is here. 0.95 everything is multiplied by 10. 9 has gone to the left hand side. The remaining values are here. Like that, for every number, if you see, even a number has a 0 as a value in the first place. When you multiply by 10, 0 will go, other digits are all here. So now if you look at it on the left hand side, then the lowest possible digit would be 0. So after the multiplication of 10, 0. Highest could be 9 as well. Now if you apply on the same thing, if you apply explicit cast, I'm sure you must have gone through the explicit cast video. So I'm going to explicit cast. I will get a range of value from 0 to 9. See here. Oh, sorry. One moment. So if you see here, after multiplying by 10, 3 must have gone. Integer side of 3 point whatever is 3. So as 8. So as again 8. So as 9. So as 7. So as 7 again, because it's a random number. Number can repeat. Here repeated again. 6 and so on. If I run this second time, new set of values will come. So 5 multiplied by 10 must have been 5 point something. Integer side of 5.7 is this. So option 1, I can straight take an integer after multiplying. I'll get a range of value from 0 to 9. So if I don't run this line and I straight run this, I'll get only single values which has already been converted multiplied by 10 and then explicit cast has taken place. Option 1. Now, on this number, I can also apply the ceil or the floor functions. What is a ceil? Ceil is always rounding off to the higher side. So I'm going to show you again this. Okay. I'm also going to keep this because we need to know what the value is, and I'm going to copy this and paste it over here first. And I will say the Math.ceil of this. Ceil is always higher side. Now if you logically look at it, the lowest digit that you're going to get is 0 point something. The highest digit that you're going to get is 9 point something on the left hand side after we multiply by 10. So if I have 0 point something, higher side is going to be 1. Of course 1 will be point something will become 2, 2 point something will become 3. So at the last value 9.0 will become 10 point something. So I'll get now the range of values from 1.0 to 10.0. So I'm going to get 100 numbers straight generated. You see here, and we'll see evaluate each one of them. So if I go from top, the original number generated is this. When we multiplied that by 10, 6 has gone onto the left hand side. Now once it is gone to the left hand side, this number if I ceil it, because it's 6 point something, higher side is going to be 7.0. 9 point something, 0.9 something multiplied by 10, the 9 digit has gone onto the left hand side, point everything. Now 9 point anything, even if 0.00009.0.00001 also, it will make it to 10. So as 5 point something will make it 6, 7 point something will make it to 8, and so on and so forth. So somewhere you will find also a value 1 may have been generated. Alright, so that must be 0.0. So let me just find out very quickly here. So this number is 0.0008 something. If I multiply by 10, the first digit 0 has gone on to the left hand side. That's the lowest digit. But then it has something over here. So even if 0.00001 also, it will become 1 because it's ceil. So now if I actually look at it and I disable these two lines, I don't want the calculator straight. I want the number to be multiplied by 10 and ceil it. It is going to give me in range from 0 to 10. Oh, sorry, 1 to 10. My mistake, 1 to 10. 1 is here, 10 is over here. You will never find a 0. 1 has come again. 1 has come again. You can see. Okay, 1 has come 4 times. It's a random number anytime. Then it is 10 also has come. In between, of course, all digits are there. 10 has come again. You can see the numbers have been generated. So this is generating numbers from 1.0 to 10.0. Now if I really want a number, once I get it and only without 0.0, then I just have to cast it. If I cast it, you will see all the numbers from 1 to 10 without decimal point because you've done the casting. So 1 is also present, 10 is also present. Of course 2, 3, somewhere you will find 4 also. You can see 5 also, 6 also, 7 also. You can see 8 also. Somewhere you will see 9 as well available. Of course here. So all the numbers have been generated. So I hope you understood if the number is applied like this. Now on the same thing, if I'm going to apply floor. Now 0 point anything, if I put it to the lower side, then the value will be 0. 0.5 also, the lower side of that is 0. So floor will give me a number 0. At the same time 9 point anything will give me a lower side of that is 9. So floor is going to give me a range of value from 0 to 9. Okay, so if I'm going to remove this directly first to show you. Okay, so every number generated we multiply by 10 and then we floor it. So you can see here. So if I'm going to start from here, 4 multiply by 10, all this is going to bring the first digit on the left hand side. Floor of this lower than this number is 4.0. Again lower than this number is 4.0. So when I come here 1.3, everything lower than this number is 1. So as somewhere you will find 0 here. There you are. 0.0. If I multiply by 10, 1 0, this digit has come this side, everything else is here. Now if you see 0 point anything, lower side is going to be 0.0. So I got the lowest number 0.0. Somewhere you will find also the number 9 must have come. Okay, something 0.9. So let us see if we can find anything, right, where some, yes, there we are. So the number is 0.93. If I multiply by 10, the first digit, last digit has gone to the previous place, okay, the integer place. So 9 point anything is going to be converted into 9. So I'm getting on the left hand side, all right, the digits. Then I floor it, okay, so it will give me 0 to 9. So if I disable these lines, then this will give me a range of values from 0 to 9. So if you see 9 is here, okay, somewhere you will find 0.0 as well. So here, there we go. So if the same value is multiplied like this with the floor, the values are 0.9. If I'm going to cast it, then I'll get directly the number without decimal point. So 0.0 is removed and I've got here the number. So 9 is the highest number, 0 is the lowest number. So I hope you've understood. Floor will give you 1 to 10 if you're multiplying by 10. Okay, sorry, not floor, my mistake. Ceil will give you 1 to 10, floor will give you 0 to 9. Okay, and the last one that is left is, you don't need actually for that int. The last one that is left is round. If I round off, then I have all the chances of getting a number from 0 to 10, because if the number is 0.4321 whatever, then the round off will be 0 side, lower side, whereas 0.567 and everything will go higher side. So the 0 point something has a greater chance of coming lower as well as higher. So as 9 also, the round off of 9.1234 will take you to the 9 side, whereas 9.56789 will take you to the 10 side. So your lowest is 0, highest is 1. So round is going to give you range of value from 0 to 10. Okay, so I am just this time I'm not going to enable this straight number of values generated here. If you look at this, then of course 1 is here, 9 is here, somewhere 10 is easily found, 10 is again found here, 0. So you got a range of value. You can see 0 again because it's a random number. 10 has come, 0, 10, you can see. So this is giving you random numbers from 0 to 10. Now based on your program, you will have to decide what type of value, range of values that you are looking at. Computer will generate that number. Now I'll give you a simple example. Okay, there is a simple, let's see if it is here. Yeah. So here is a program, let's say very simple program. I am asking user to select one number from 1 to 6, assuming you are throwing a dice. Okay, and you are playing a game of chance. That's okay, I am choosing 4. So computer will also select one number between 1 to 6, match with your number and see whether you have guessed the correct number or not. So computer has generated 5, I have selected 4, the answer is false, so I lost. Again I run this program and I say okay, 5. This time computer has generated 1, I have taken 5, again I lose. Again I take a number, let's say I take 2. Computer has generated 3, I still lose. It's not that computer is purposely choosing, it's just that computer has got randomly selected number, alright, and it's not matching with my number. So if I keep on taking 2, some point of time I will come right. Is it? Still not right. So someday we can try. So you look at this program. What is this program? Very simple program. I have asked user to choose one number. So I used to choose all the numbers. Alright, and immediately I am printing what you have selected. Now I am taking a ceil of a number, alright, which is multiplied by 6. So whichever number, if you use ceil is always 1 to what number? So 6, since I am multiplying. So the last number computer will generate if I multiply by 6. So the highest number 9 point something, 9.56, whatever is going to be, 9.5 into 6 is 5.4 or 5.5 something. So if I ceil it, it's going to make it to 6. The lowest number computer could generate is 0 point something. If I ceil it, it will become 1. So 1 to 6 number generated, I convert into integer. So computer will show me. Then I'm matching. If my input value is equal to what is generated value, I win or you win, or you lose. It's a very simple concept. So last time I'm running, let's assume the number generated is 2, I still generating 3. Okay, so here also, if you look at this, we are generating a number. Okay, now if you round it, it's 0 to 10. If you ceil it, it's going to be 1 to 10. If you floor it, it's going to be 0 to 9. Now this is a number which is going to help you to generate a number. It's always from which to which number. So if I say 25, then round will give me 0 to 25, ceil will give me 1 to 25, and floor will give me 0 to 25. Okay, 0 to 25. So if I increase this number to 100, this will give me 0 to 100, ceil will give me 1 to 100, floor will give me 0 to 100. I hope you guys have understood this. I'm just taking random numbers. So here, some number, if you see lowest 2 has come, of course, somewhere 100 also may come, 0 has come, of course, you can see 0, 100 will come, 0 has come again, 100 has not come because it's a random number. So if I run it again, I may have got 0, somewhere I may get end up getting 100 as well. So I hope these numbers, no, still not got 100, so we take a random again. Somewhere we should get 100. So if I don't get, don't worry, you will still get at some stage. So let me make this a little greater values. So more numbers will be generated at one shot, and I'll be able to get you 100 probably at some stage. So 0 you have seen it's already come. If it, yeah, there you are. You can see 100 has also been generated randomly. So you will find the lowest being 0 and highest being 100 because it's 100 has come again, because it's round. If I'm going to ceil it over here, it's always going to be 1 to 100, and if I'm going to floor it over here, it's going to be 0 to 100, 0 to what do you call 0 to 99, I believe. So it's going to be going to the lower side. So even in 25, it's going to be 0 to 24. My mistake must be, alright, 0 to 24. So this is 0 to 99 somewhere. If you can see 99 being generated, 0 has already come. 100, this must be ceil. This must be ceil. So 1, what have I done? Let me see. No, it's still round. So if I'm going to make it ceil, sorry, my mistake. So ceil will always give me 1 to 100. Of course, decimal value will come because I've not converted them. So if you look at this, it's going to be lowest value is going to be 1 somewhere. 100 has already come. Somewhere, yeah, 1 has also come. At the same time, if I'm going to floor it, so you'll get 0 to 99, not 100, because the lowest number that I can get is 99 point something, which will get down, alright, compared with or rounded off to 99 point something. So the lowest number I should get 0, but the highest number I should get 99. So 0 I have already got. Somewhere 99 will also come at some stage. It's a random number. Up to 98 it has come. 99. No, 100 will come. Okay, because it's floor. So I hope you guys have understood this. Now the last thing that is left is, what if I have to generate a number between some number to another number? So I'm going to take you to a very simple explanation. So let's say here, I want you to generate a number, let's say between 75 and 100, or from 75 and 100. Let's assume that you have to generate a number 75 to 100. How do you do this now? Okay, so in this case, what you need to do is you need to generate a number from 0 between this, the difference between these two. So the difference between these two is 25. You will generate one number from 0 to 25. Now, how do I get 0 to 25? Obviously, we are going to multiply a number with using round. So we already have here round. You can see, okay, if I write round over here, then obviously when I'm going to say 25, it is going to generate you a number from 0 to 25. So I generated a number. That's a difference. 0 is here. You can see somewhere 25 will also be there. Yeah, 25. So we have got the numbers 0 to 25 already present. Now what you need to do is, since you got a number 0 to 25, which is a difference between the lower and the higher number, you generate a random number over here. So if I say here that the number is, let's say 0, 1, 2, 3 up to 23, 24, 25. Now I'm going to add the lower number of the two to this. So if I'm going to say plus 75 in all cases, so this is 100, this is 99, and this is of course 75, 76, 77, 78, and so on. So what you see is the numbers between one to another. So what you need to do is you need to generate a number of values which is a difference between the higher and the lower number. You generate a random number, you then add the lower of the two. Okay, so if I'm going to go back here and if I'm going to add the lower of the two, which is 75, then computer will generate now all the numbers from 75 to 100. So 76 I can see here, 76 is still appearing. So let's see if the number is able to come. 99 has come, of course, still. 100 has come. You will find 75 also at some stage. 76 has been repeating quite a good number of time. Yeah, 75. So you'll get a 75 to 100. So now if I want between 100 and 200, or from 101 to 200, then the difference is 100, and of course the lowest number is also 100. So this will generate you a random number from 101 to 200. So 101 is here, straight. Okay, at some stage you will get 200 as well. So this is how you will be able to generate the random numbers, right? So in your exam you can be given a value like this and say what range of values it can print. Then you should know the range, ceil, floor, and round, as I explained earlier. I hope you all have understood and enjoyed this session. Thank you very much. We will stop our explanation here. I hope you had a good time with the math function. Thank you very much. God bless.